Good morning, children. Welcome to the physics class. Today we are discussing about examples of force at a distance. Examples are magnetic force, electrostatic force, and gravitational force. Before discussing about these examples, once we recall the definition of force at a distance. The force which occurs without any physical contact between the two objects is known as force at a distance or field force. I repeat, the force which occurs without any physical contact between the two objects is known as force at a distance or field force. Now moving to first example, magnetic force. Now we will learn magnetic force with a simple activity. Take a needle, rub it with the bar magnet several times, always moving in the same direction, then the needle acts as a magnet. How to do this? I will show. Take a needle and a bar magnet, rub the bar magnet on the needle several times, always moving the magnet in the same direction. Then the needle gets magnetized and it behaves like a magnet. We know that every magnet has two poles, north pole and south pole. To identify the south pole and north pole of this magnetized material called needle, fix a red color ball at south pole and blue color ball made up of thermocol at north pole with the help of a compass. Fix a red color ball at south pole, white color ball at north pole with the help of a compass. Similarly, make another needle in the same way, then the another needle also gets magnetized. Now we have two magnetized needles. Okay, now drop the two needles in a bowl containing water. Get what happens. We know that like poles of the magnet repel each other, unlike poles attract each other. Means the south pole of the first magnet pushes the south pole of the second magnet, north pole of the first magnet pushes the north pole of the another magnet. Means there is a push between the like poles, and the south pole of the first magnet attracts, means pull the north pole of the another magnet. Means the push or pull between the poles is nothing but magnetic force. The action of push or pull is nothing but magnetic force. Next topic is magnetic field. We will learn magnetic field within another activity. Take a bar magnet, place it on the table, and take a cardboard sheet, place it on the bar magnet. So the bar magnet is under the cardboard sheet. Okay. Now sprinkle some iron filings on the white cardboard sheet. Iron filings is nothing but small pieces of iron. Sprinkle it on the white cardboard sheet. Next, tap the cardboard sheet gently, means very slowly. Tap the cardboard sheet very slowly. Then the iron filings are set themselves in a pattern due to the magnetic force of a bar magnet. Due to the magnetic force of a bar magnet, the iron filings are arranged themselves in a pattern. We can observe the pattern in the last diagram. So this pattern represents the magnetic field. Now what is magnetic field? Definition is the space around the magnet where its influence can be detected is called magnetic field. I repeat, the space around the magnet where its influence can be detected is called magnetic field. For example, if we place any other magnet or magnetic material in this particular region of the bar magnet, that second particle experiences a force by the bar magnet. The second particle which we place in this region experiences a force by the bar magnet. Now I will explain a simple example. For example, any of our friend comes to our house. we will restrict them. You have to sit here, you don't touch that pen or mobile phone or something. Means we are influencing them. Similarly, here the second particle is influenced by the bar magnet. Clear? Any other particle which is present in this field influenced by the bar magnet. Okay. Now, if we observe the pattern, these particles are arranged themselves in the form of lines. Okay. Curved lines, straight lines, we can observe the different types of lines in this pattern. These lines are called as magnetic lines of force. These lines are called as magnetic lines of force. So once you observe the figure last one, so these lines are not uniform. In some areas they are very closer. The area in which those lines are closer, at that particular area the strength of the magnet is more. The area where the lines are closer, the magnetic lines are closer, in that area the strength of the magnet is more. So we can observe the strength of the magnetic is more at poles. Now, next example, electrostatic force. Before discussing about the electrostatic force, we will observe an activity. Take a balloon, inflate it and tie up the open end with the help of a thread. Now, cut a paper into small pieces and place it on the table. Rub the balloon with white paper and bring the balloon near to the piece of papers. What happens? Observe the video. Take a balloon, inflate it and place near to the piece of papers. See here, the piece of papers are attracted by the balloon. Why the piece of papers are attracted by the balloon? So initially the balloon is rubbed with a paper. By rubbing with a paper, it acquires an electrostatic charge. Sir, what is electrostatic charge? Each and every object has positive and negative charges in it. If it is equal in number, it becomes neutral. So by rubbing it with the white paper, the balloon loses some of the charged particles and it becomes a charged object. It loses negatively charged particles and it becomes positively charged body. So when it is closer to the piece of papers, so automatically the piece of papers acquires a negative charge. When it is placed near to the piece of papers, those piece of papers acquires a negative charge and these negative charged particles are attracted by the positively charged balloon. Means the force exerted by a charged body on another charged body. Here negatively charged body and positively charged body are try to attract each other. So this force of attraction is known as electrostatic force. I repeat the definition. The force exerted by a charged body on another charged body is known as electrostatic force. Now our third example, gravitational force. So generally gravitational force is a common example, common experience in our daily life. If we project an object into upward direction, it reaches the ground after some time. Or if an object slips off from our hand, it falls down to the floor. Why? Because there is a force acting on the object to pull it down towards the earth's surface. That force is nothing but gravitational force. So this gravitational force acts on each and every object on the surface of earth or close to the earth. This gravitational force acts towards the center of the earth. The direction is towards the center of the earth. And one more, there is a force of attraction between any two objects in the universe. Between you and me, between you and the remote, or between you and the mobile phone, or a chair and the wall, there is an attractive force between any two objects in the universe. But this attractive force is negligible when compared with gravitational force. And this force of attraction is also depending upon the mass of the objects as well as distance between them. Okay, so the gravitational force acts towards the center of the earth. Okay, good. So total 3 examples we discussed: magnetic force, electrostatic force and gravitational force. These 3 are examples of force at a distance. There is no contact, physical contact between the two objects in the 3 examples.